Welcome students, welcome to the video class. Today we will do some questions, then we will move to silent features of Coulomb's law. ठीक है? The first question is, four charges Q, Q, minus Q and minus Q are placed respectively at the four corners A, B, C, D of a square of side A. Calculate the force on charge Q placed at the center of a square. ठीक है? Again, four charges Q, Q, minus Q and minus Q are placed at the four corners A, B, C, D of a square of side A. So let us say the square is A, B, C, D, and the four charges, this is Q, this is Q, this is minus Q and this minus Q, are placed at the four vertices. ठीक है? And the square has a side length A. So A, this is A, this is A, this is A. ठीक है? And calculate the force on charge Q placed at the center of the square. At the center, we are having another charge, that is capital Q. We have to find the force on charge this Q. ठीक है? Okay. तो square रो, this is A, this is A, this is A, this is A. तो diagonal केते होगा, that is root 2A. तारा half केते होगा, this length, that is root 2A divided by 2, that is A by root 2. So that means this is A by root 2, this is also A by root 2. This is A by root 2. This is also A by root 2, this is also, this is also. ठीक है? Okay. Okay. Now let us find the force on charge Q due to the charge present at A. So ठीक है? Let us say this is FA. So charge Q will be repelled by charge at A. So let us say this FA. ठीक है? तो FA कितने होगा? 1 by 4 pi epsilon naught. Charge is Q, and this is distance is A by root 2, the whole square. ठीक है? Similarly, charge Q will be repelled by the charge Q present at B. So let us say the force is FB. So charge Q will repel charge Q in this direction. So let us say this is FB. The magnitude कितना होगा? 1 by 4 pi epsilon naught. Charge is Q. Distance is A by root 2 the whole square. ठीक है? Okay. Charge minus Q will attract charge Q in this direction. Charge minus Q will attract charge capital Q in this direction. So let us say FC. So F0 magnitude कितना होगा? 1 by 4 pi epsilon naught. This is negative, this is positive. So this negative charge will attract this positive charge towards itself. तो हमें direction दे दीजिए, magnitude लिखिए. तो magnitude कितना होगा? The charge is Q and second is minus Q नहीं, only Q. Magnitude is Q रहेगा. Distance same, A by root 2 square. Okay, similarly, charge Q will be attracted by minus Q towards itself. Direction कौन होगा? FD. तो FD कितना होगा? FD is equal to 1 by 4 pi epsilon naught. This is Q by A by root 2 the whole square. ठीक है? If you see all the four charges, these all are equal in magnitude. So we can say this is FA is equal to FB is equal to FC is equal to FD. तो let us say this is equal to f. ठीक ଅଛି ओके तो यदि एठी देखिबा f a direction this f a let us say this is f f c direction मध्ये this ठीक अछि तो हमें एमते लिखिबानी तो f a is equal to f c that is equal to f हमें डायरेक्टली लिख दबा केते that is 2f एपटे मध्ये सेम थिंग fb fd अछि both are equal तो हमें डायरेक्टली लिख that is 2f what is the angle between them 90 so this is 90 degree if the two forces are perpendicular resultant is the square root of both the vectors sorry so that means let us say f net is fn so it is the okay this is the root over of the square of the two charges that is 2f rho whole square plus 2f rho whole square this is how much 4f square plus 4f square so that is how much 8f square that is 2 root 2f what is the magnitude of f so that is 2 root 2 magnitude of f is any one that is 1 by 4 pi epsilon naught this is q it is a by root 2 square so you can say this is a by sorry a square into 2 ठीक है तो this is 2 2 4 कटिला तो रहला केते this is root 2 by 4 sorry root 2 by pi epsilon naught q by a square q by a square ठीक है तो the net force on the charge q is root 2 by pi epsilon naught q by a square ठीक है let us do the question by changing the nature of the charges तो सेठी हमर थिला 4 charges q minus q and minus q तो let us change that to plus charges the question is 4 charges q and q are placed respectively at the four corners a b c d of a square of side a calculate the force on the charge q placed at the center of the square ठीक है तो again there is square that is a b c d ठीक है तो let us say the charges are q this is q and this is also q ठीक है तो center is this center charge q so all are positive charges and center that is charge q is there all are positive charges and center madhya positive charge capital Q so the charge q will be repelled by charge at point A in this direction let us say FA again charge q will be repelled by the charge small q placed at A in this direction so what will be the magnitude FA is equal to 1 by 4 pi epsilon q by A by root whole square so similarly that charge q will be repelled by the small charge q present at point B in this direction so this is FB ठीक है तो FB is equal to same तो charge q will be repelled by the charge small q present at C in this direction so this is FC magnitude and charge q will be repelled by the charge small q present at point D in this direction so let us say FD so FD to magnitude and all the magnitude are same all the magnitude of FA, or you can say the magnitude of FA, FB, FC, FD are same. So let us say it is F. तो जे देखिबा FA A direction, तो हमें यहाँ नीचे that is FD in this direction, F. So these two are equal in magnitude, opposite direction, they will be cancelled. So FA will be cancelled by FD. Similarly, FB A direction also, that is FC A direction, so that is also F. So that means FB and FC are having equal magnitude, opposite direction, so they will be cancelled. So that means on the charge Q placed at the center, all the forces are cancelled out. So net force on the charge Q is, the question is, three charges Q, Q and Q are placed at the vertices of equilateral triangle ABC of side A. Find the net force on a charge minus Q placed at the center. ठीक है, तो there are three charges placed at the vertices of an equilateral triangle. So this is Q and this is Q and this is Q. ठीक है, and the side length is A. A fourth charge, that is minus Q, is placed at the center. ठीक है, तो we have to find the net force on the charge minus Q. Three equal charges on a symmetrical figure. We have to find the net force on a charge placed at the center. ठीक है, the charge placed at the center is minus Q. So this is minus Q. Okay, so charge, let us say this is A, this is B and this is C. This is A, B, C. Charge placed at vertices A, that is Q, will attract the charge minus Q towards itself. So let us say this is F1. ठीक है, बोल से करियो. Okay, so this is F1. Similarly, charge Q placed at B will attract minus Q towards itself. So this is let us say F2. Charge Q placed at C will also attract the charge minus Q at the center towards itself. So this is F3. ठीक है, तो magnitude लिखियो F1, F2, F3. So if you say this is A and this is, so if this is A, this is A, this is A, तो सेंटर जो गोटे परपेंडिकुलर ड्रॉप करिया तो एटा केते हबो A/2 एंड एंगल केते टोटल एंगल इज 60, तो दिस इज 30. हमको A लेंथ बाहर कर रहे हो, तो लेट अस से दिस इज x, so that is cos 30 is equal to, that is A/2 by x, A/2 by x. ठीक है, तो x is equal to A/2 cos 30, so that is A/2 cos 30 is how much, √3/2. So answer is how much, A/√3. So that means this distance is A/√3. This distance is A/√3. This is and this is also A/√3. ठीक है, okay. तो F1 रो मैग्नीट्यूड लिखियो, तो F1 is equal to, that is 1/4 pi epsilon naught. Charge is Q, this is minus Q, so that is Q minus Q लिखियो नहीं, only magnitude लिखियो, that is Q. Distance is how much, A/√3 square. ठीक है, तो it is in upward direction. F2, that is 1 by 4 pi epsilon naught, that is this is minus q, this is q, distance is same, that is q by a by root 3 square. So F3 more the same, that is 1 by 4 pi epsilon naught, this is q by a by root 3. So that means we can say this is F1 is equal to F2 is equal to F3. All are equal. ठीक है. So F2 रो direction is this way, F3 रो direction is this way, and all are F. ठीक है. तो हम एटा को F2 को हम F लिख दो, एटा को F, and this is also F. Okay, what is the, तो F2 और F3 यदि compare करिया, F2 and F3 angle is how much? 120 degree. तो तांको भितर angle is 120. We will find the resultant of F2 and F3. तो let us say this is Fn. तो कितना होगा? That is F1 square, sorry F2 square plus F3 square plus 2F2 F3 cos 120. F2 F3 are equal, तो represent करें, that is F रे, so that is F square plus F square plus 2F square cos 120 is minus half. तो F square is how much? 2F square, 2 को 2 कटला तो minus F square. तो this is F square and this is F. तो resultant कितना आसियो? Resultant force F NB, that is equal to F. So if you see, जब देखिबा A dita resultant is this, that is Fn, that is equal to F of B in anti-clockwise direction. F1 force put, that is also equal to F. So that means F1 and F net will cancel each other. So net force कौन होगा? 0. The net force acting on the charge minus q placed at the center is 0. So that means हमें कही परिया, if we take symmetrical figure, whether it is triangle or that is square or that is hexagon or this is pentagon, anything, if it is symmetrical figure and if you place equal charges at the vertices, यदि equal charge vertices से रखिबा, तो center रे whether you place a positive or a negative charge, तो net force on the charge placed at the center is 0, whether it is plus or minus. यदि plus रखिबा, that is this is on over, this charge will repel this charge in this direction, this charge will repel this charge in this direction. So cancel is you same thing, A dira force cancel, A dira force madhu cancel. So that means all the force will be cancelled out. So that means if it is a symmetrical figure and if you place equal charges at the vertices of that geometrical figure and center is यदि कोटे charge रखिबा, whether it is positive or negative charge of any magnitude, net force on the charge is always 0. ठीक है. The unit and dimension of charge. In SI system, the unit of charge is coulomb, and in CG system it is, that is state coulomb or AB coulomb. ठीक है. And यदि dimension देखिबा, the dimension of this charge is, तो हमें जानचे current I is flow of charge, that is Q by T, or Q is equal to I into T. ठीक है. तो if you यदि dimension लिखिबा, तो एथरे mass नहीं, m0, length भी नहीं, time अच्छी, that is t1, and that is current अच्छी, current unit is ampere, so that is a1. So the dimension of that is charge is m0 l0 t1 a1. ठीक है. Next we will find the relation between, that is coulomb and state coulomb. ठीक है. Next is the relation between coulomb and state coulomb. again the relation between coulomb and state coulomb. ठीक है. For that, let us consider two charges, each 1 coulomb, separated by 1 meter in air medium. Again, consider two charges, each 1 coulomb, separated by 1 meter in air medium. ठीक है. तो तांके भितर फोर्स थिबो. तो in SI system, okay, the force between them is 1 by 4 by epsilon naught. This is q1 q2 by r square. ठीक है. वैल्यू कितने होगा? That is 9 into 10 to the power 9 into the two charges are each 1 coulomb. So this is 1 into 1. Distance is 1. So that is 9 into 10 to the power 9. The force is 9 into 10 to the power 9 Newton. ठीक है. So the topic is the relation between coulomb and state coulomb. So let us consider this 1 coulomb is x state coulomb. ठीक है. Let us consider 1 coulomb is x state coulomb. ठीक है. Okay. तो जदि सेम फोर्स टा आमे सीजी सिस्टम लिखिबा तो कोन होबो? तो 1 coulomb बदल दिस इज x state coulomb, this is also x, and the distance between them कोन होबो? 100 cm. ठीक है. तो वैल्यू लिखिया, the value of this same force in CGS system. So F is equal to 1 by 4 by epsilon naught. The two charges is because 1 coulomb, but in CG system we have taken 1 coulomb is x state coulomb. So it कितना होगा? The two charges are x into x. This is x, this is x. Distance is 100. So that is equal to 1 by 4 by epsilon naught. In CG system it is 1 into x square by 10 to the power 4, and the unit of force in CG system is dyne. So this is x square by 10 to the power 4 dyne. Okay, the two forces are same, only this is in SI system, this is in CG system. So we can say the two forces are equal. But जेतोला में equal करूचे, एठी न्यूटन अछि, एठी डाइन अछि, तो मैं कन्वर्ट कर दवा डाइन को न्यूटन रे. So that is x square by 10 to the power 4. So 1 dyne is 10 to the power minus 5 Newton. 10 to the power minus 5 Newton. ठीक अछि. एबे both the unit is same. लिखिबा तो 9 into 10 to the power 9 eta, and this force is x square by 80 minus 5 अछि 80 आसिला into 10 to the power minus 9. Eta 80 हम दवा 9 into 10 to the power 18 x square. तो x is how much? 3 into 10 to the power 9. तो value of x is 3 into 10 to the power 9. ठीक है. तो हमारा assumption थिला that is 1 coulomb is equal to x state coulomb, that is कितना होगा? 3 into 10 to the power 9 state coulomb. ठीक है. And outer relation is 1 coulomb is also equal to 1 by 10 AB coulomb. ठीक है. Data relation actually one is 1 coulomb is equal to 3 into 10 to the power 9 state coulomb, and the second is 1 coulomb is also equal to 1 by 10 AB coulomb. Next is silent features of Coulomb's law. ठीक है. The first feature is Coulomb's obtained the law through experiment. So say by experiment he has proved this law. So it is basically a experimental law. ठीक है. Next is Coulomb's law is strictly applicable to point charges at rest. So it is strictly applicable to point charges which are at rest. Third is Coulomb's law is an interactional force. This is important. जेतବେଳେ ଆମେ charge नवा 2 point charges Q1 Q2 so they produce electric field around themselves. Then there is an interaction. So that's why it is called an interactional force. And this the force जेतବେଳେ बाहर करिवा so this is force on first charge due to the second, and this is the force on the second charge due to the first. The two charges are equal in magnitude and opposite in direction. Coulomb's law is an interactional force. It means the force exerted by one charge on the second is equal and opposite to the force exerted by the second on the first. The two forces are equal and they are opposite in nature. ठीक है? Next feature is Coulomb's force is not affected by the presence of other charges at the neighborhood. Again, Coulomb's force is not affected by the presence of other charges in the neighborhood. Okay, let us consider an example. Let us say a charge Q1 is present in air medium, and on its neighborhood another two charges are present. So let us say Q2 and Q3. Again, charge Q1 is present in air medium, and on its neighborhood another two charges Q2 and Q3 is present. Let the distance between this Q1 Q2 is R12 and this is Q1 Q3 is R13. Since they are all positive charges, they will repel each other. Let us find the force on charge Q1. So Q2 will repel Q1 in this direction, F12. So what is the magnitude of F12? So F12 is equal to 1 by 4 by epsilon naught. This is Q1 Q2 by R12 whole square. ठीक है? So Q3 will also repel Q1. That is F13. Direction magnitude कौन होगा? F13 is equal to 1 by 4 by epsilon naught. This is Q1 Q3 by R13 whole square. Okay, listen. This force F12 depends on Q1 Q2 by R12 whole square. It is independent. This force F12 is independent of the charge Q3 present at the neighborhood, or we can say this force F12 is not affected by the presence of Q3 at its neighborhood. Similarly, I mean F13, it is 1 by 4 pi epsilon Q1 Q3 by R13 whole square. So this F13 is not affected by the presence of Q2 at its neighborhood. बुझिल ना? जो Q1 ऊपर Q3 force पकोची, that is F13, it does not depends on the presence of the charge Q2 at its neighborhood. Coulomb force is not affected by the presence of other charges at the neighborhood. This Coulomb force is independent of this charge. This Coulomb force is independent of this charge. Okay. Next feature is Coulomb's force hold good for very large or small distance up to 10 to the power minus 12 meter. And last is Coulomb's force is attractive for unlike charges, and this is repulsive for like charges. Let us consider two charges Q1 Q2 separated by distance r in a given medium. The force between them is equal to 1 by 4 pi epsilon. This is Q1 Q2 by r square. So this force, Coulomb's force between the two charges, depends on the charges, depends on the separation between the two charges, and also depends on the medium permittivity. The magnitude of Coulomb's force is depends on magnitude of charges, separation between them, and nature of the medium. It depends on magnitude of charges, separation between them, and nature of the medium. And last is the direction of the force. So let us consider three charges. This is Q1, this is Q2, and this is Q3. So all are positive charges. They will repel each other. यदि हमें Q1 पर force बाहर करिबा तो Q2 will repel Q1 in this direction. Q3 will also repel Q1 in this direction. So the direction of force depends on the orientation of the charges. Orientation means position. So this force depends on the position of Q2. This force depends on the position of Q3. So that means the force depends on the position of other charges. Okay. So the direction of force depends on the orientation of charges.